My name is Gustavo Reyes, and I'm going to talk about the mechanical design for our project. Well, first of all, we have the fixture. The fixture was designed so it could hold the the components we were going to weld. There were six of them, so we had to hold the six of them together all at once, and at every single angle the piece could move to. For this we created a fixture that could hold them either they were facing up or downwards or they were rotating, because some of the pieces were held up in one direction and others in the other. We used clamps for this, as well as we used some bars that worked as support. All of this also taking into account that the welding spots we were going to do were sometimes on this side, on the outside, and sometimes on the inside, and we couldn't cover them with our fixture, so the robot could do those welding spots. So we also took that into account, so every welding spot is clear from the fixture. Then talking about the layout we selected was to give some space for the robot to be working on, as well as a space on the other side for anyone to come in. The the positioner we used rotates, and it helps us have one of the tables or one of the fixtures on one side for an operator to be working on loading or unloading a new piece, and the robot working at the same time on the other side, as well as we have a safety mat that lets know the system if there's someone in, so it doesn't rotate and it's no danger for anyone inside it. There's also the emergency button, also signs people should be working with safety equipment, as well as we have for the cables we have cable management, so if anyone goes in, the robot's not pulling the cable too far. This is the layout also with all the measurings we have. Now the robot with the tool for to adding the flange for the robot to be able to grab the tool in which in this case it's the laser head. We used the its own flange that it already has for this type of robot, but we also had to focus on which robot we could pick. In this case, the one we picked has a 15-kilogram payload, and when we analyzed the payload diagram and the reach diagram, we got into the conclusion that this robot was going to be able to both reach with the size of the fixture and the tool or the components we were going to weld, and also was going to be able to hold the fixture without any problem on its load capacity. Finally, for the vision system, the system we selected was the Inside 7800, 800 by 600 in color. And the lens is the 4.5 millimeter. Why did we do this? Well, our main issue with the vision system, I'm gonna go back to the workspace, to the layout, so I can show you. The vision system's up here in this crossbar, and the distance that we were taking into account that it would be apart from the fixture was around 1.2 meters. So we went into Cognex's website and gave out that the working distance was 1.2 meters, that the field of view was 3 meters by 60 centimeters or zero point 0.6 meters, and it gave us a field of view, or sorry, it gave us the length of the lens that we required, so that's why we used the 4.5 millimeters, which would be able to help us do any kind of inspection to see if the weldings are okay or if there's any components missing. So mainly that would be it. All of this is following ANSI standards and also looking for the best way for it to be functional, operational, and also easy for any operator to use as well as to understand. Thank you.